goes beyond that universe is going to be noise instead of signal, and it's going to confuse all the things you're trying to understand. So you want to try to find a data collection that is very topical towards the exact problem you're trying to study and solve. The next thing is, instead of having just predefined annotations, you have the features you can discover on the fly based on what's in the data. So the data helps you understand what's there through the features that are uncovered. So the way that you understand the data is through these discovered features. Next, it's dynamic processing. The reason it's dynamic, you can't just do everything in batch, is because there's a certain level of interactivity that's going to take place here. That interactivity involves the human analyst understanding what's been found and making changes to the detectors, to the algorithms, to the approaches to take advantage of what's there that's interesting and ignore the stuff that's there that's not interesting. And that definition of interesting is critical there. You can't know ahead of time what each analyst is going to find interesting. So the same approach can't work on every single situation, even with the same data. It really depends on the objectives of the analysis. Versus, instead of supervised learning, it's really more of an unsupervised approach. Really has to do with discovery, and so approaches like clustering are very important. I think it's more than just your typical unsupervised clustering algorithm, though, because there's no right answer. You know, you usually think about clustering as, okay, there really is a set of classes out there. I'm really trying to discover them somehow in the data without the use of a ground truth data set. That's the supervised approach. And the unsupervised says, well, I'll get rid of that ground truth, but I'll still try to understand those as an input, but I'll still try to understand those categories that I think are the right categories through my unsupervised algorithm. This kind of unsupervised learning doesn't assume that there's a right answer. It assumes that what's useful is actually good. And what's useful, again, may depend on the situation. And so it requires a level of interactivity. It requires kind of an open-mindedness that a lot of these other approaches don't always have. And instead of precision and recall, we talk about interestingness. We talk about utility. And I like to talk about the interesting wrong answer. Just because an answer is wrong doesn't mean it's valueless, in the sense that it may point us in a totally new direction that we weren't even thinking about when we defined what we thought was interesting in the first place.
How do you compare this to the other things that have been discussed here of late? Decision-making is often discussed as part of data mining, things like the Netflix, where you're taking in lots of data and trying to make decisions about what movie to show users, or the Yahoo people who came in and said, well, let's find out how long a given article should be shown to people, because it seems to cross between the two categories and not satisfy either one of them very nicely.
That's a very good point. And I think when I think about how I'm sounding here, it does sound like I'm a little bit negative towards the confirmatory and real positive towards exploratory. Keep in mind, I'm very prejudiced about this. You know, I do all this all day long over here, and that part I'm doing a lot less of, so I think this is really great, and that's not so interesting. But it's not true. I mean, I really understand that the algorithms developed by Netflix contest and the other algorithms are really great, and I hope we can do more of them. But the difference is, in the Netflix contest, you had all this ground truth data. You had all these people who had, ranked these movies and had really, confirmed that those were the good recommendations. This kind of exploratory analysis would really be to look for those kind of hidden associations or completely undetectable things that might tell you something about a whole new business opportunity that Netflix never even thought of doing. It's really talking about what you're not necessarily looking for as a known business, but the things that are out there that are really surprises. Hopefully we'll see some of that, and we'll talk about the examples in a moment. Another way to think about this kind of duality here is it's like reductionism versus holism. So reductionism is the idea that I can take the universe, break it into nice pieces. Each of those pieces I can break down further, And eventually I get to points that everything is a very straightforward equation that I can solve. The trouble with that is each time you do one of those simplifications to look at a smaller and smaller piece of the universe, you're leaving behind something, you're assuming something, you're making things a little bit too simple. And there's an overall complexity that you're ignoring for the purpose of making things testable and mathematical. And there's both an advantage and a disadvantage to doing that. And holism tries to look at things differently and say, let's look at the whole picture and let's not leave anything out. Let's let the data kind of tell us what might be going on that we're not thinking about, that we're not expecting. Let's not make too many assumptions going in. And maybe we'll find something we didn't expect at all and come up with a whole new kind of hypothesis to test. And as Aristotle said, the whole is more than the sum of its parts. Reductionism is great. It can certainly have a lot of power, but you need to keep the whole thing in mind. So, I don't mean to be negative about, the confirmatory approach is very valuable, but there are some limitations to it. Ground truth. I'm sure those of us who practiced data mining a while know this is always a problem, and ground truth tends to be an oversimplification in many ways, because what if there is one expert, or a very limited number of experts, who you're relying on to label this data, and you're not really sure they represent the world as a whole. You're making a lot of simplifications in the ground truth data in many cases. It only represents the past. It doesn't represent what's going to happen in the future. So there's a lot of weaknesses there. As I said before, precision and recall tends to miss the interesting wrong answer. Just because an answer is wrong doesn't make it uninteresting. Things are not always all that repeatable in the real world. So whatever you did learn on a previous set of data may not be all that practical in the new situation when you've got a new analyst, a new business, a new set of problems. That approach may not work so well. When you start to optimize things, whatever your criteria for optimum is, it may not be the same for another situation, another person, another business. They may find your optimum to be useless. And overfitting, I see this so often, that people take whatever data they have and they'll build the perfect solution for that data. And they try. Don't mean they're being irresponsible in their testing and their building of training sets and testing sets and so on, but it's very difficult to get a really representative sample of the universe in your data. You're probably going to wind up, overfitting it to a great degree. Just recently, to kind of confirm everything I've sort of been saying up till now, this article came out about a month ago in the Atlantic magazine titled "Lies, Damn Lies in Medical Science." And I think it's really kind of bringing home the importance of this dichotomy between confirmatory and exploratory. The problem is that, as you probably noticed in medical science, a lot of the research articles that we see wind up getting overturned over time. We see a study will come out and say, vitamin X, if you take vitamin X, you won't ever get cancer and heart disease will be cured and, all these problems will be solved. And then, 5 years later, 10 years later, someone will go back and relook at the data, maybe add in some more stuff and realize, oops, sorry, we were wrong. Well, how did that happen? Why does it keep happening? Well, this guy, Dr. John Ioannidis, actually went back and did a very thorough study of all these kind of mistakes that were made, and he kept seeing this pattern over and over again. Researchers were continually making the same mistakes. Their studies were biased. And what they were doing every single time was essentially letting their own desires about the research impact the actual analysis of the data. Their own hypothesis going in was essentially becoming a part of the results they were getting at the other end. And the odds are that in any large set of data, and we know this as data miners, you're going to find some connections, you're going to find some patterns, no matter what, if you look hard enough, if you've got enough data. So you've got to be very careful about this. And the thing we ought to be aware of is that we can't just point the finger at medical research. This is true across every research discipline. There's always going to be forces outside the data, forces outside of the scientific discipline that encourage the researcher to find results that aren't there. And it distorts every single field of science. And so, you know, my mission in life is to get people to kind of see this, maybe take a step back and look at the data in a different way, so that they let the data tell them what is actually going on in the world, as opposed to them trying to make the data say what they want it to say. Yes?
So is this attributed to a collective failure of the body of reviewers?
There's certainly a lot of blame to go around, and reviewers is one area where things I think have fallen down in science, in the sense that people don't see that as their main job, and it's not, you know, they spend enough time really validating the papers they read. And then another thing is, a lot of these disciplines don't really have kind of this, what I think of as kind of the scientific pope. There is no one who's really in charge. It's just kind of a societal meme that kind of goes on and on and on in the same way, without really worrying about, at some objective level, are we getting better, are we getting worse? No one's really doing this kind of meta-level study to see whether research as a whole is going in the right direction, and that's a problem. Not really have a really good fix for that, but it is something that worries me, and I think it should worry all of us.